Good day, viewers. We are still treating roots of complex numbers. I promised you that you are going to appreciate questions. So I have this question. Find the square roots of the complex number 4i. How are we going to solve this question? Okay. So first of all, remember that when you have 4i, this basically means we have the real part of the complex number, which is what? 0, right? Then plus the imaginary part of the complex number, which is what? 4i. So as a result of that, you have what? Your 4i. Now when I employ Jane Argand diagram, in other words, Robert Jane Argand diagram, or for simplicity purpose, you employ the Argand diagram or the complex plane. When you graph this, you are supposed to get this. If you are new here, kindly visit my previous lectures where I have treated Argand diagram into much details. In fact, we are going to appreciate the complex plane. So we have our imaginary axis here, and we have what? Our abscissa or our x-axis. So when I plot this, 4 is going to be what? Yeah, 4 is here, right? That's the vertical axis. Okay. Now, this 4 clearly, this 4 is my r. Because remember, we said if you want to find for r is you square the real number part, then you square the imaginary part. Is that not so? So this is my a, and this is what? My b. So therefore, I have what? 0 squared plus what? 4 squared. So I have what? Square root of 16, which is 4. Alright? Why is this positive? It's positive because modulus represents what? A distance. And we are not considering negative distances, okay? Positive what? Distance. That's why we took what? The positive what? Modulus. So therefore, we know that from this side to this side, the angle here is what? Is 90 what? Degrees. Is that not so? So when I convert this to radian, this is the same as what? 180 over 2. So this is pi on 2. So pi on 2 is the same as what? 90, because pi is 180, then over 2, which is what? Our 90 degrees. So therefore, and I can also say that my r, what will be my r? This is what? This is my r. The length, okay? The length of this line becomes what? My r basically. So therefore, I can say that my r is also equal to what? 4. So my angle is 90 degrees or pi on 2 radian, and my modulus is what? Is 4 from here. So now from the formula, we know that this, cos alpha plus I sine alpha this way. Is that not so? Good. So if that is the case, what is my m? Whenever you ask this question, find for the square root, find for the cube root. Cube means 3, right? To the power 3. So n becomes 3. Find for the 4th root, n becomes 4. But here we have what? Find the square root, so square 2. So therefore n is equal to what? Is equal to 2. Then my r here equals what? Is equal to 4. As simple as that. What can we also do here? Let's look for the angle. Okay, but we have what? What do we have here? We have pi on 2, right? But we can still do this. We know that that is the theta, okay? This is the angle theta. But we are not looking for theta, we are looking for what? Alpha. And I say that we know that alpha is equal to what? Theta plus what? 2 pi k over what? Over 2. So where k ranges from 0, 1, 2, then to n minus 2. Number of what? Tens. Okay? So where k ranges from 0 and what? And 1. 0 and 1. two distinct roots called square roots. You get that? So as a result of that, we are just going to do what? Substitution, since we know the angle. Alright? So substituting this, we have, remember we said n is equal to 2, r 4, and we know that alpha is equal to, that's theta plus 2 pi k all over n. Okay, where k ranging from that 0 and to what? To 1 because of square root, right? So by substitution, saying that, so we can say that when the value of k is equal to what? 0. If k is equal to 0, what is the angle over here? So this is so simple. We have alpha is equal to, what is the angle? Theta. Theta, so the angle theta, where? Pi on what? On 2, okay? So the angle theta, we say pi on what? On 2. So I have pi on 2, then plus 2 pi, then times what? Times k. But I said k, when k is what? 0 times 0. Then all over what? N. What is the value of n? 2. This way. So I have pi on 2 plus what? Plus 0. Then all over 2. So when you compute this, 2 to 4, right? So we have pi over what? Over 4 radian. As simple as that. So this is the angle alpha for, that's when k is what? Is 0. So therefore, I can substitute alpha here, okay, using this formula. So I know that now, when, okay, let's do this. We found for when k is equal to 0, right? Let's look for the angle. Or, let's consider when k is also 1. We've considered the situation when k is equal to 0. Let's consider the situation where k is equal to 1. Okay, so that we can finish on time. So what happens when k is equal to 1? So when k is equal to 1, so what happens? This one happens. So I have alpha is equal to, this is the formula. Set pi, that's 0. Sorry, this is the angle, okay? And the angle is equal to a pi on 2. Is that not so? Then plus 2 pi, then times the k. But when k is what? 1. So times 1 all over what? All over 2. So this gives, that's pi on 2, then plus 2 pi on 2. So this is the same as, that's 5 pi, right, on 2, then over what? Over 2. So therefore this angle is equal to, that's 5 pi on 4. Okay, so this angle is true when you have a positive integer of what? Of 1. Do you get that way? 2, the square root, it has 2 distinct roots. So let's see how we can incorporate this into the formula in order to solve the question. Okay, so for want of space, let's come here. So say when k is equal to 0, from here, we said alpha, that the angle alpha is equal to pi on 4, right? And we already know that n is equal to 2, I is equal to 4. N is equal to 2, then I is equal to 4. So, recalling the formula, I know this, right? Because alpha plus I sine alpha, as simple as that. So therefore, what is my n? N is, I have 2 here, this way. Then I have my r. My r here is what? 4. then multiplying cos alpha. Viewers, be very, very careful. We don't use what? We don't use theta here. Why? We assume theta is not the amplitude, it's not the true angle. The true angle is always what? Is always alpha. So therefore, we are going to use alpha. Then times, we have what? Pi on 4. Then plus I sine what? Pi on 4. So when I compute this, we are getting 2, then 2 multiplies cos, then pi on 4. Please, we are working in radian, okay? Then I sine, then pi on 4. So by the help of the calculator, we have 2, then cos pi on 4 gives this. So we have, when we compute this, we have square root of 2 over 2, then plus I, then when we compute this using the calculator, sine pi on 4 also gives square root of 2 over what? Over 2 here, as simple as that. So clearly, this multiplies that. So I have 2 times square root of 2 over 2, then plus, then this 2 multiplies this, I root 2 over 2. This cancels this cancels this. So therefore, the answer is square root of 2 plus I, then square root of 2. This is what? One of the roots, because we started from when k equals what? 0. So when k is equal to 1, what happens? Remember we said our alpha was this. When k is equal to 1, from here, here's the value for the alpha. 5 pi on 4. Then the condition still holds. You have n is equal to 2. The r is also equal to 4. So using this formula again, we have n. Okay, you have the nth root, okay? So we have cos alpha plus I sine alpha. So I have, you know that the whole of this, which is this, give us 2, right? So I have 2, then by the help of, okay, so I have cos, what is the value for alpha? We have what? 5 pi on 4. So I have 5 pi on 4. Then plus I sine, then 5 pi on 4. This way. Viewers, this is what we have, okay? Yeah. So we have 2. We are working in radians. So when you compute this, okay, using your calculator, you will get negative root 2 on 2, then plus, okay, then I have negative I, okay, or in other words, negative times positive gives what? Positive, that's negative, right? So I have minus, I have my I, then root 2 on 2, okay, then you multiply. So I have 2 times negative root 2 on 2, then minus these 2, then times I, then I have this, okay? So clearly this cancels this also cancels this. So therefore the answer is what? Negative root 2, then minus I, then root what? Root 2. As simple as that. So therefore, the roots of the imaginary number are, what do we have? We have negative root 2 minus I root 2, and the one we had over here. this. So positive root 2, that's positive root 2 plus I root 2. Viewers, this is the end of the lesson regarding roots of complex number. Okay, we are considering when you have a square roots. I'll also bring you another trick, okay, very fast, simple and convenient way to solve what, or to find square root of a complex number. If you want to really know this, click on the subscription button so that you can get all my updates. Thank you for your time.